Hello and welcome to today's shenanigans. This is a large number when it comes to what take it is. I'm not very good at recording myself doing things. Let's get started. Today we're going to use Edmay's awesome IDF2PH, which is a plugin that allows you to build your PHPP up from Rhino. Now here I have a model of the original passive house, but it's not complete. As you can see, it's not going to match your example PHPP explicitly, but it's a work in progress. So what we're going to be using is a number of tools, namely IDF2PH, which is awesome. It makes doing passive house stuff much easier. It's quite nice. Now what IDF2PH does is it piggybacks on Ladybug and particularly the honeybee workflows of utilizing Energy Plus. Now what Energy Plus is, if you don't know, is the Department of Energy's big, awesome building physics simulation engine. It can do all sorts of stuff, like you can have material inputs for green roofs in your model, and it accurately does all the math to interpolate how your green roof will impact your building energy model. And that's just one of 847 pages worth of shenanigans in the engineering reference, and then there's also the input-output reference. You can learn all about it. I believe I've attached a link to the documentation on the resources file that I attached in the tutorial material. Now what we're going to be doing is taking those tools and building up an IDF to populate the PHPP. Now an IDF is, as you can see, just a really long text file that has lists of all the surfaces, all the systems, and all the relevant data for the building energy model. Now if you use Visual Studio's code, they have a nice Energy Plus syntax highlighting, which is pretty cool, especially if you do any work with IDFs with Python and the likes. But back on track, what we're going to be doing is taking that PHPP and using Wallacei, which is something that when I was very new to Rhino and Grasshopper, I stumbled on and didn't know what it was. I had no idea what evolutionary multi-objective optimization and computation is, but I looked at this primer and I thought, this is important. I'm going to save this, and when I get to a place where I know what it is and how to use it, I'm going to use it, because I've always been, I wouldn't say overwhelmed, but there's so many variables and so much that goes into designing buildings, especially passive house, where the orientation, the placement of the windows, the type of the glazing, all the values and data for each part of the envelope, let alone the systems themselves, they all in my brain are kind of like number sliders. You know, if you pull one, they're linked in a way that the other ones move. So if you have a less efficient ERV, for instance, you're going to need an even better design as it comes to solar intentional or intentional solar heat gain and insulation and all that other stuff. So this seemed like the way to explore all the objectives via all the variables that go into designing and building passive houses. Now, let's break it down and simplify it a little bit. What is a passive house? Now, a passive house is a building that, when it passes, the heating demand is at or below 15 kilowatt hours per meter squared annually. Now let's ignore all the other ones for right now. We have an energy goal. Now, a lot of people have an association with passive house that it costs more than other buildings, which can be true, but how do we, with this heating demand and the reduction of, correlate reducing cost? So what I've been obsessing about for a little while is using our awesome evolutionary multi-objective optimization and computation engine to take those goals and the genes, the variables related, and design a passive house. So what we have up here, if you have open the files and documents that I kind of tried to prepare a little bit for this with is group 1, which is some insulation information. I used a national construction estimator to pull some data, converted it into the correct values. We have some costs as well. Now in group 2 we have some windows. All these values are out of the certified components list in the PHPP. Not necessarily is this entire assembly out of the PHPP, but the values are just kind of mixed and matched and grabbed. I didn't want to actually express anyone's real product to avoid any sort of weirdness thereabouts. And then in group 3 we have Ed's really good ERV, which you'll learn about in his tutorial videos if you want to learn more in depth about IDF2PH, which I highly recommend. We have Martin's not as good ERV, and then my cat ran across the keyboard, and that's how we got 36. So that's his ERV. Now let's get started and go ahead and grab some geometry from here and push it into here. So let's go ahead and make it 2 stories. No, let's do 1 story for now. So we go here, and then let's go up. Let's go 3 meters in height. Yeah, that'll be nice. Cool. So let's go ahead and select that. Come over here, double click on the canvas, and let's get a B-rep. Now let's set 1 B-rep, internalize that data, and kill the explicit over here in Rhino. Now we're going to make this window smaller because we're going to be in Grasshopper for a little bit. Okay, so first thing we're going to want to do is deconstruct this B-rep so we can get these 2 side edges so we can build up a roof off of that, because we're going to have the roof angle as one of the variables, because I have this weird thing about there has to be some kind of form that's a variable. Okay, let's go ahead and do that. So let's get deconstruct B-rep. Go ahead and throw that into here. Now we have all the faces. Let's go ahead and hide that. We have all the faces, edges, and vertices. So what we're going to do is, we have 8 of these. We have 12 of these. Yeah, let's go with vertices. What we're going to do is get an item selector. If you have Honeybee and not human, you'll have your own item selector from Honeybee as well. But these are particularly from the plugin called Human. So let's go ahead and do this. And let's find which ones are what we're looking for. So look for the ones that the last ones are 3. And these are both the same one. Oh, nope, perfect. Now let's, can we tween a point? Huh. Actually, I don't know if that's stock Grasshopper. Let's do it this way. We're going to make a line, start point, end point, and then we're going to get the middle of this line. Line middle. Not curve middle. Curve middle. We're going to grab this. Now let's go ahead and grab the other side of the model's points as well. Let's do item selector 1 more time. Copy that. Here we go. Here we go. And now, nope, wrong one. Yep, that one. And cool. So let's do the same thing. Let's make a line. Start, end. Let's go ahead and square this up. OCD is showing. Curve middle. Let's go ahead and copy that. Now we have these 2 points, right? And we want to move them up. So let's go ahead and drop a move onto the canvas. We're going to put both of these points, hold down on shift, put them into the geom. Now what we're going to do here is get unit Z. The vector Z is where we want to go, so those are going to move up, right? Now we're going to have some fun. We're going to get a gene pool. Go to edit, gene count 2, decimals. Let's just do 1. Let's keep the simulation from being too heavy right now. So minimum, let's do 0.25. And then maximum, let's do 3.25. I just said we're going to only use 1 decimal, huh? 3.2. Perfect. And let's hit OK. Make this smaller. Put that in here. And now when we move these sliders, each of these points is going to move individually. So maybe we'll get some fun stuff out of the other side. Now, a surprise tool that's going to help us later is, let's go ahead and right-click and rename our gene pool, WLC_1. It's a surprise tool. It'll help us later. It's a good time. All right, now we need to make lines coming off these points to the corners so we can make our roof surfaces. So let's go ahead and line. Now we have these, and we have these. So we're going to need to make 4 of these. Now let's select this corner, which is that one. Go over to the start point. And the way that you organize where your start points and where your end points are, you're going to want to have consistent. Otherwise it twists. It'll get messy otherwise. Just trust me. So we're going to go from here to, I believe it's going to be the first one. So let's go list, item, and just pop out another block. Compress this a little bit because we're going to get messy soon. Just double check, point. Let's go here. That's not the one we want. We want the other one. Perfect. Now we know. So dang. There we go. Now let's kill that. Let's get another one of these, and we'll have that start point be here and here. Cool. We have some lines for that side. Let's do the same thing with these other 2. Throw that in the start, throw that in the start, throw that in the end, throw that in the end. Cool. Okay, let's go. We're going to loft these real quick to make our roof geometry. So let's go ahead and drop a loft out onto the canvas. For the curves, these 2. Perfect. That wasn't what I was trying to do, but we needed to do that. Is this the wrong loft? That's weird. Why you do that? Oh. Here we go. And then we're going to go ahead and once again, we're going to this is the 40-second take, so I'm a little fuddled up. Let's get another loft. We're going to go from here, and finally we have our roof surface. Cool. Let's go ahead and compress all this a little bit. Nice. Okay, cool. So we have our roof surfaces, we have our main B-rep. Now what we need to do is, I know there's a couple different ways to do this, but we're going to do it the weird way and do boundary surfaces for these, and we're going to have those as walls. So let's go ahead and drop a couple boundary surfaces down. I have this line is from these points. Now we want the edges, list item. I wish I remembered the way that all of this was organized. There we go. Thanks for bearing with me there, guys. Alright, so we have this one, and we have this one, and this one. So what we're going to do is drag this over here, drag these over here. Let's put that one on the bottom. We'll do here, here. That is that curve, and we're going to add this one. And boom, we have our other chunk of the wall. Let's go ahead and drop these in here. Let's get another list item. Let's do Control C, Control V. Come down here. And I believe it was that. Nope. Yep, there we go. Add that into there. So now we have a surface there too. Perfect. Nice. Let's go. Let's go ahead and drag these up here. Now before we get super far, we want to have the walls as their own surface. And by that I mean their own we create surface, so we can individually control glazing by ratio on each of the wall surfaces rather than the entire building. So we have 4, so we're going to copy this 3 times after we drop it. We'll have these ones included with their corresponding side wall. Let's go to list item. Now since this is a box, it's going to have 6 faces, so let's go ahead and 1, 2, 3, 4, 5. We have our list. Nice. Let's go ahead and just unpreview this so I only have one at a time. Let's grab these and preview off as well. Preview off as well. Preview off as well. And quick pause.